so many students are coming in the campus, then situation may go wrong very fast. So before the situation go out of hand, it is desirable that most of the experiments, at least you will be knowing how to do and why you are doing. So this is the aim. Is there any discussion on this? Any question by anybody?
All clear.
Anybody else?
No, sir.
What is no? It's not clear?
No, sir, there's no problem. It's clear.
Okay. So
Everything is clear, sir.
our aim is clear, that we try to finish up all the experiments. We should not. There was a proposal that we make the experiment half, and I didn't like that one, because if you make the experiment half, that means half of the things you will not be knowing also. So better let us try to do everything, everything, but in a shorter way. So my purpose, I will now show you some slide presentation, not slide presentation, some screen presentation, where I will tell you what are the practicals we have in the syllabus. Okay. When you speak, please switch on the video. Who wants to speak? Switch on the video. What happened, Anukul?
Hello.
I think you are logged in a multiple device.
Good morning, sir.
Yes. Yes, I can hear you. Tell.
Hello. Good morning, sir.
I can hear you.
Yes, sir. Sir, actually, the problem is that presently many classes are running in a very irregular manner. Sometimes the professor enters the class. Sometimes there is some network issue or some problem. So that's why today no one was able to come to the practical class, and we were not able to know that the practical class would be conducted or not. So it's a request to you, sir. Please inform beforehand to us that tomorrow will be the practical, so everyone would be able to reach the lab on time.
Okay. Once this practical or any theory practical timetable has been displayed, it is expected that all the classes will be on time as decided, unless the teacher informs you. Okay, that is the reason of this disclosing the timetable. Timetable is not variable. Timetable is fixed. If a teacher wants to take class in other time, do not want to take class, then it is the teacher's responsibility to inform you.
Okay, sir.
So there is no need of doubting that whether my class will be there or not. If my class is not there, I will inform you that my class is not there. If my class time is changed, I will inform you. Otherwise, you must talk to the teacher. Okay. So
Okay, sir.
timetable is fixed. The teacher has the teacher. At 1 minute. Good morning. Theory class I'll call you back after class. Sure. So, so
Excuse me, sir.
if a teacher is not taking class, you talk to the teacher. Vidhi, switch on the video camera and talk.
Sir, actually, I don't have earphone with me right now. That's why I can't switch on the video camera.
There is no relation between earphone and video camera.
So, sir, but I can't. I will not be able to speak now. That's why I said.
Yeah, I can listen you. No
Okay, sir.
problem.
Sir, I wanted to ask you this: that today will only be the instructions, or practical classes will be held also.
Today only instruction.
Okay, sir.
Anybody? Okay, so if there is no other query, then we can I can show you. Just and in between, I want to say that I have created a Google Classroom. That classroom joining is must, because every class, whatever is instructed or whatever you have done, that must be scanned and submitted online. So joining of classroom is must. So right now I will
Hello,
show that how many students has joined.
hello,
So
sir.
this is the classroom I am showing you.
Hello, sir.
Yes.
Sir, I am Kartike, sir. So the problem was that, sir, my mail was not approved by the different type of professors.
Your
And
name
today,
is?
today I have just,
I
today I have,
Yeah,
okay,
you
okay.
remove your mask. You are
Yes, yes, sir. Yes,
online
sir.
virus does not
No, no.
speak. Huh.
Okay, okay, sir. Sir, actually, sir, I have sent one mail, sir, to you, and that was regarding the new mail update. So let it join in your Google Classroom, such that I will also got the news, sir, recent
Just
updates.
let me see your name.
Kartikeya Raj.
Okay.
So yes, sir, and that was Kartikeya Raj 0302 @gmail.com. Now, right now, it is Raj Kartike 989 @gmail.com.
So you see I have sent you invitation Kartikera 0302.
Yes, sir.
So you mean to say this is not your valid email ID?
Yes, sir. This is
Then
not.
how did you join this class? I have invited you this one only.
Yes, sir. So let it send the new mail. So what's about the mail that I have just sent? So add also that mail, sir, such that I will also got the invitation link or
No,
something else.
it will be difficult to if I keep on sending to different ID, because finally I have to. Okay. What is your classroom? CH? How much?
Sir, it's not CH, it's BOT. So because I was in botany honors, right now I am just in the chemistry.
Okay. Just a minute. Kartike Raj.
Yes, sir.
Huh. What is the email ID you want?
Raj Kartike,
Yes.
RAJKARTIKE by
KARTIKY
989
989.
@gmail.com.
Why you keep on changing your email ID? What you get out of that? Is it okay? Whatever is written, can you see on the screen?
Just let me check, sir.
Hmm?
Just one
Just,
second, sir.
just a minute. I think I did something. Noise. Okay, let me go to get back. I wanted to do something and
It's showing.
there is some problem. 1 minute.
Okay. So it's Raj Kartike 989 @gmail.com. Yeah, that's nice.
Okay,
But
so
but the KE by sorry, it's not written KE by. Only K by is mentioned.
what happened?
Raj Kartike KE by. You have just only written K by.
A
E
EY.
by. Yes, sir. Yes, sir. No. No. Okay, sir. No problem.
So can you change mine to please?
Don't start that business. Now I cannot keep on changing everybody. Kartike. This is the one you don't want.
Yes, sir.
Where it gone? Yeah, this is the one you don't want.
Yes, sir. Yes, sir. That I don't want. Only Raj Kartike 989 @gmail.com.
fine.
Yes, sir. Yes, sir.
So I have invited you.
Okay, sir. Then I will just join right now.
Okay, so these are so many people did not join, but I just created. So I request all of you to join it. This is very important. Okay, so now, so I have invited other two teachers also, just now. So this is the scenario. So next is that we are trying to I am trying to tell you what are the things are there in the practical. So these are the practicals we have. This highlighted one. Okay, this is a highlighted one. Practicals we have. The practical that I will be taking are these two. These two I will be taking. Okay. So viscosity. This is my name. So I will be taking this one. And these are the practical will be taken by another professor. PP Solanki. Today he is not here, so he will not take. And another two practical will be taken by another teacher. Okay. So this one is the PP Solanki, and this SM stands for S Manivara. S Dr. S Manivara. Now, what are the practicals? Practicals are viscosity, density. Viscosity. Uh, uh, Actually, we'll be finding the first practical that today we will be giving instruction. So we'll be finding, or I will give instruction for the both because we have enough time and a good number of students. Let me see how many students are joined. Can anybody tell how many students have joined? It's 40, no?
40 students.
I think some more are joining, maybe 43. 43 joined. And what is our class strength? Oh my goodness, is 90. So 90 is the class strength, and then only 40 has joined even online. I don't know what is the sincerity that the students are showing. Online, what is the problem in joining? Did you tell all of your friends that class is going on online also?
Yes, so we informed it in our unofficial chemistry group also.
With WhatsApp also?
Yes, sir, on WhatsApp only.
Oh, still people are not joining. So what do you want to me that I give instruction both the experiment or one experiment?
So both the experiments.
It is always good that we should try to finish as early as possible, so that in case again it is class is stopped, at least you will not be losing. You will be at least knowing that this practical can be done this way. So you know that still 40,000 cases are going on, and when this kind of online opening, offline is opening, then it will drastically. Last time when we opened the offline, then immediately 60-70% of the faculty got infected. Anyway, so you see that first is the Viscosity, have you done? Hello?
So can you please repeat because there was some network
Students?
issue and your voice was muffling.
Acha, okay, network issue. I am asking that did you measure viscosity in your first year practical class?
No, sir.
No, sir.
Okay, because you have not done any practical class so far, is it?
We have done
Or you have
titrations in our first semester.
okay, okay. So then it will be new, but actually ideally it should not be new because we have made the syllabus in such a way that first year you can do this viscosity measurement, and then third year you will be using viscosity to determine the composition. Anyway, it is not a difficult experiment. It is not a difficult experiment. So this experiment is that viscosity, by the measurement of viscosity and density, one can determine the composition of ethyl alcohol water mixture. Say, what does it mean? Say, I have a glass containing a mixture of ethanol and water, and you don't know what is the percentage of ethanol in it, whether it is a 20% ethanol or 40% or 80% or 100%. It is not known to you. In that case, how you will determine the percentage? So it can be determined easily by the measurement of viscosity or by the measurement of surface tension along with the density. So density have to be measured, that is common. But along with density, if you measure viscosity, then you can determine the composition separately. If you don't measure viscosity but you wish to measure the surface tension, then also through surface tension measurement you can tell the composition. This is very interesting thing. Now, first experiment is that how to tell the composition of a binary mixture, how to tell the composition of a binary mixture by viscosity density measurement. Okay, our aim is clear, all of you.
Yes, sir.
I am asking all of you, our aim is clear.
Yes, sir. Clear.
Yes, sir.
So right now I am trying to show that how does the can you see that on the screen?
Yes, sir.
Can you see? Okay.
Yes, sir.
This is a glass apparatus whose name is Oswald. Whose name is Oswald.
Oswald
OSTWALD.
viscometer.
Oswald glass
Viscometer.
viscometer. So this looks like this. This is made of glass. So if I go to the other slide, one minute. Okay. So let me go to here, and we have several images. I just want to take out one good image. Hmm, maybe this image looks good. This looks good. Copy image, and then is it okay?
Yes, sir.
Can you see what I am showing?
Yes, sir.
Okay, the beauty of this online class is that I can do anything if I have a good internet connection. So that glass apparatus, it is shown here. So you see there are two bulbs. Two bulbs. This is a smaller bulb, this is a larger bulb. This bulb, which is written as a bulk A, actually it will be bulb. This bulb is actually reservoir. This is the working bulb. What you do is that you fill the bulb by using a rubber tube here. Let me get the power pointer. Okay, so this is the bulb. Is it clear now? You have to fill the bulb.
Yes, sir.
You have to fill the bulb. You use the rubber tube here, suck the liquid from here. You take maybe 12 ml. It will be fixed amount, 12 ml. Take 12 ml here by a pipette, and then use a rubber tube here. Rubber tube here to suck that liquid. Liquid will come through this tube, thick tube, to capillary tube. This is a capillary tube, fine capillary tube. So liquid is, since you are sucking, so this liquid, or maybe I should go to this pen mode. Okay, so this is the liquid, and you are sucking the liquid. Liquid is coming through this way, 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 and it is depositing here. Fine. Okay, so your liquid should be up to this much. You have to fill this liquid here by sucking. Here you suck using a rubber tube, and then this liquid will come up here. If it comes up here, it will initially it will come here. It will come here. Then you allow it to flow. So when it comes here, when the liquid layer comes here, then you start counting the time. Then you start counting the time, and then keep on counting the time. Means you will have a stopwatch, or nowadays people use mobile, the best option, better, much better than given stopwatch. Mobile is much reliable. So you start when the liquid come here, from here on the top, because you have sucked, so you will be sucking up to this layer, and then release the pressure, and it start coming here, and it start moving here, and then you keep the stopwatch on. Maybe you need to have 129 seconds. So this is the time of flow. This is called time of flow. What is happening? This liquid is flowing down through what? Down through a fine capillary tube. That capillary tube is here. Down through a fine capillary tube. What you are measuring? You are measuring the time of flow for certain volume of liquid. Is it clear?
Yes, sir.
What you are measuring?
We are measuring the time of flow for a certain amount of liquid.
Yes. Good. Just a minute. Somebody wants to join. They are great people, those who join now. Khushbu. Khushbu? Khushbu,
Yes, sir.
what is the time now?
Sir, 11 2.
Can you switch on the video?
Sir, uh, sir, 1 minute.
Hmm?
Sir, not in condition.
But you are supposed to be in the lab from 10 o'clock.
Sorry, sir.
You are entering in the lab at 11 o'clock after 1 hour.
Okay.
What okay? This is not okay. You cannot enter in the lab after 5 minutes. Remember, at least in my class.
ओके सर, सर थोड़ा टाइमिंग में प्रॉब्लम थी, पता नहीं था कितने बजे से। सॉरी सर, अगली बार से नहीं होगा।
क्यों क्यों? टाइम टेबल नहीं है तुम्हारे पास?
नहीं सर, है तो सही।
टाइम टेबल नहीं
है सर, है।
तो कितने कितने बजे लिखा था टाइम टेबल में?
10 o'clock था सर।
And then you are entering at 11 o'clock. Where are you? Inside the campus, BHU?
यस सर, आई एम इन BHU ओनली।
So you came to the class, practical classroom.
सर व्हाट?
Don't do like that, okay?
सिग्नल्स आर नॉट गुड एक्चुअली।
Huh?
सॉरी सर, अब नहीं होगा।
Yes,
सॉरी
don't do
सर,
like that. 5 minutes is enough. After 5 minutes, you should not disturb the class. So many people are disturbing the class. Okay, so we were discussing. Okay, again we are going back. So let us slideshow. Okay, then pen, then pen. Okay, so now our layer was here, and then it start decreasing. When it passed this layer, then we stop counting time. Say that count time we counted is 129 seconds. We count in second. We do not count in fraction of second. We just count in second. Okay. So now, since you are passing this liquid through the capillary, fine capillary, this is the fine capillary. Through the fine capillary, this movement of liquid or this motion of liquid or the time taken by the liquid to pass from here to here, complete passing from here to here through the liquid, depends on the viscosity of the solution. So if your solution is highly viscous, it will take more time. If your solution mediumly viscous, it will take some time. And if your solution is very light, no viscosity, no, it's light viscosity or low viscosity, like a water or so in that case it will be less time. So time measurement will give you the viscosity value. So with viscosity value, that viscosity value along with density value will plot and get the composition. That I will be telling you right now. So this is this Oswald viscometer. This Oswald viscometer so is will be used in the laboratory. Is it fine? What you will be using, I have told you.
Yes, sir.
Okay, end show. Now I will show you this is also okay, this remain. Now I will show you that where you will get the instruction. So all the instructions will be available in my website if you do not have yet. My website I am typing. You see, this is very simple. www.satyen.saha. Exactly my name and surname together. There is no tricky in that. My name in correct spelling, my surname in correct spelling together.com. Is it okay? And then you go to course material. There you have, according to BSc first semester, second semester, and then BSc third semester, and then BSc 5th semester. Can you see the BSc 5th semester here written?
Yes, sir.
Yes, sir.
Yes, sir.
So it's not that all the things are there which I usually take. I have kept it. So here you have seen that there is a PDF file, viscosity composition and surface tension composition. Click it.
Yes, sir.
I clicked it and it is downloaded. Okay. Can you see the downloaded one?
Yes, sir.
Runmi Kundu. Runmi Kundu.
Yes, sir. Hello.
Can you switch on the video?
Yes, sir. Sure. Sir, I came to the vaccination center for the first dose. That's why I joined late.
Okay. What is your name? Runmi or Runki?
Runmi. RUNMI. Runmi.
Okay. Okay. So in this class, do not enter if it is more than 5 minutes or maximum 10 minutes.
Sure. So next time
Okay.
if you not. Okay.
Yes, yes. Uh, what I was showing is anyway, I am showing the PDF file. So this is the determination of composition of given binary mixture, ethanol, water, from the study of viscosity composition curve at a lab temperature. This is the instruction I am giving. Fine. So in this, the apparatus you will be using, I have shown, I have discussed. If there is any confusion with the apparatus, then you can tell, you can ask me. The equation you will be using is a well-known one you have studied in your theory, which comes from the Poiseuille's law. Viscosity coefficient eta is equal to pi r to the power 4 Tp divided by 8 VL, in which I'm just making it bigger so that it appears nicely in your mobile, even if you're using mobile. Eta is pi r to the power 4 TPVL. Okay. Now R is the radius of the capillary that I have shown you. R is the radius of the capillary. It is radius R. T is the time of flow that I have told you. Time of flow, how much time it is taking, how much time it is taking. Ravishing, ravishing. So R is the radius of the capillary, L is the length of the capillary, and P is the hydrostatic pressure. That means through air, that whatever the solution is getting pressure on it. These are the component. V is the volume of the liquid. As I said, that if you are taking 12 ml, that 12 ml volume, it should be fixed. Now it is the viscosity, as I said. Now what you have to do is that we use this equation. So this is actually we are trying to get the composition by the relative viscosity. Relative viscosity means we will have another standard sample like water, and measure the viscosity of the unknown solution with respect to the water. Okay,
Sir,
so
how we will calculate the hydrostatic pressure?
that we are
It
going
will be
coming.
given or we have to calculate?
That we are coming. We are coming. Soon we are coming. So now this one, this equation, eta is equal to pi r to the power 4 Tp 8VL. If it is happened that we are measuring two things, one is our solution, unknown solution, another is a known solution. Known solution means water, because water ka viscosity we know. Using the same viscometer, in that case, since in this case, in this equation, eta is proportional to hydrostatic pressure and time of flow. Eta is proportional to hydrostatic pressure and time of flow.
So,
Same viscometer. So volume is constant, length of the capillary is constant. Class later. Volume is constant because we are using the same viscometer for measuring both water and unknown solution. L is constant because the same viscometer, capillary length is same. R is constant, pi is constant, 8 is constant. So eta is proportional to P and T. And hydrostatic pressure depends on your gravitational force and the density and the height of the liquid. In this case, the density only changes, because height, gravitational force, all are same in your desk. On your desk you are doing, there is no change. So eta is proportional to rho. Rho is the density of the solution, GHT. So if you are doing the experiment at the same height, not today in BHU and the water in BHU and unknown alcohol on the top of the Everest, if you don't do like that, if you do both on your desk, then the eta is actually proportional to rho and T. So if you measure two things, means one is for your unknown solution, which is known as 1, another is for your unknown known solution, which is known as 2. So eta 1 by eta 2, if you do ratio, then it will be rho 1 by rho 2, T1 by T2. Rho 1 by rho 2, T1, eta 1 by eta 2, rho 1 by rho 2, T1 by T2. What is we need to know is the eta 1. Eta 2 is the standard sample viscosity value that will be given to you. So eta 2 is known. Viscosity ratio rho 1 and rho 2 and time ratio T1 and T2 you have to find out through experiment. So the experiment we will do to find out the time measurement and viscosity density measurement. So our purpose of doing this one is that measure the density, measure the time of flow. This one is clear to all of you?
sir, there is one question
Yes.
that is regarding, sir, if someone just asks that you have to find the relative viscosity, so it means that relative viscosity, so we have to compare it with the water only.
Yes.
So if
Yes.
there is one question, sir, like that, if relative viscosity, we have to find relative viscosity. So that relative viscosity of one with acetone and butanol, so at the same height. So in that case, if one is given relative viscosity, so one with respect to water, then we will find the relative viscosity of one, that is the acetone, with respect to water, and then again with the butanol, so we'll find the another thing, and then we will just compare it.
You see, uh, in any case, we usually measure everything relative. Even your height is relative. You know,
Yes,
Everest
sir.
ka height relative, our building height relative. Relative to what?
Someone,
Ground
someone.
level.
Yes.
Sea level.
sea level, related to sea level. So most of the things we do relative. Now the problem comes when the against what we are measuring, if that value is not correct, then only problem comes. Now in this case, we do it against water. Water being the life of reason for the life on the earth, every studies have been done with water with very high accuracy. So you have the values, in our case the viscosity value of water at any temperature at any highest accuracy level. So whatever you are finding out, that will have no error involved. Now your question, another question was that what will happen if you find out with respect to acetone, acetonitrile or any other solvent? Am I right?
Yes, sir. Yes, sir.
It should be exactly same value you will get if you have if your standard sample is correctly measured. But acetone, acetonitrile or any other solvent, it is very difficult to get exact value. For example, acetone is very volatile. The moment you start doing all these things, half of the solvent will be evaporated. Half of the solvent will run through the capillary, and half of the solvent will be evaporated through the upper level, upper escape route. So in that case, your value will not be same. But that is not because of this technique. That is because of your choice of the standard sample. So here the choice of the standard sample, water, is excellent. Is it clear to you?
Yes, sir.
What is
Got
your
it.
name?
My name is Karthikeya Rao, sir.
Okay,
Karthikeya.
okay. Good. Think and then ask. If I can, I will tell you what I think. If I cannot, I will tell you that also. Don't worry about asking question. Asking question is very important because that clears your doubt. It is, you can assume that being a teacher for teaching this one for years, I should have less doubt than you. Am I correct?
Right,
So
sir.
you can ask question to clear your doubts. Don't worry, I never get angry for asking question. I get angry for not asking question, just keeping quiet like a means you are not listening at all. So discuss. In discussion, you will know many more things. Whatever you want to know, you will know many more things. Right now, I have told how the standard sample is used. The standard sample is chosen. Why not acetone is a standard sample here? Why not? There are hundreds of organic solvent, hundreds of inorganic materials are there. Why we don't choose that one? That answer also I have given you. Is it okay,
Yes, sir.
Karthikeya?
Yes, sir. Yes, sir. Volatile nature of acetone. That's
So,
why we are selecting it.
so the more you ask, I can share what I know, and I promise you I will not give you wrong answer. If I don't know, I will tell you. Don't worry about that one. Discussion brings lot of clarity in your knowledge, and do not feel I never ever tell anybody that your question is stupid, your question is not good, nothing like that. I never tell in my life. Every question has importance. Fine.
Yes, sir.
Okay. So finally, what we are using is going to use this equation. This equation, eta 1 by eta 2 is equal to rho 1 by rho 2 T1 by T2. Fine. So in that, eta 1 is the viscosity coefficient, or simply we say viscosity. Viscosity of unknown solution. Eta 2 is viscosity of standard solution. Here it is water. Rho is the density of the unknown. Rho is the density of water. T1 is the time of flow of time of flow of unknown one, and T2 is the time of flow of water one. Okay. With this, we'll be doing the experiment. In this experiment, what we'll do, that we'll make, it is experiment. So we'll make different composition water alcohol mixture. Okay, different composition water alcohol mixture. So just a moment. Actually, I'm trying to join with another device. The device which will allow me to write something. And uh, I'm trying to present. Can you see this one?
Yes, sir.
Sir, voice is getting echoed.
Because I'm using two devices at a time.
So you can choose the option of audio off in the mobile.
So basically, you can mute yourself on one device so that the other will work.
Oh, what about now?
Yes, sir,
Now
it's
it's
much
fine,
better.
sir.
Now is it clear?
Yes, sir.
Oh, great. Who gave me the suggestion?
Sir
I choose
Nivedita.
visitor. Great, great. Yeah. See, so nice. No, if you speak, I also can learn. Okay, speak in my class. Speak something which other people also can learn, or we can have a nice discussion. Thank you, Nivedita. I was suffering for this in some classes. I didn't get this point. Okay, now I am using. You see, I can show the video. Yeah, you see, I am using the tab. So, and that one is coming there. Very good. So what I wanted to show you is that you have to prepare a sample, several composition. So you are given, say, I want to change the color. This one. Say you are given this unknown sample, some X percentage of ethanol in water. Okay, and we have to find out how much ethanol water. So for that, we are going to take help of viscosity measurement, viscosity and density measurement. Fine. So what we do is that we prepare several composition like this one. 0% ethanol means pure water. This is pure water, ethanol, and in between several composition. 20% ethanol in water, 40% ethanol in water, 50. Here 40 50 I kept too close by because the curve is this, in between these two usually a curvature comes. Then 60% ethanol in water, 80% ethanol in water, 100% ethanol in water, like this. Okay. So what we have to prepare such solution, and after this we have to measure the viscous density and viscosity for all, density and viscosity for all. So for all the composition using the same apparatus. So viscosity I told you how to measure, density I did not tell you how to measure. So for density we usually use a picnometer. We can picnometer also you can find out in the website. Picnometer is like a design 5 ml bottle, 5 ml accurate bottle having a stopper. In the stopper there is a pinhole here. So you put your solution, say this solution in 598 gram, and then empty it, clean it, dry it, and then put water. This is water H2O, and then measure it, 19.679 gram. Since the volume is same, so their weight ratio will be density ratio, isn't it?
Yes, sir.
Yeah. So we need the density ratio, isn't it? In the equation you have seen eta 1, in the equation what you have seen, eta 1 by eta 2 is rho 1 by rho 2 time 1 by time 2. So here eta 2 is the H2O time 2 H2O. So now we have this rho 1 by rho 2 for all cases. Fine. Now we need the time 1 by time of flow for the mixture and the time of flow for the water. That will independently measure it. So you will get this one. Is it okay till this point? Okay.
Yes, sir.
Okay. So if you have all the things, then you have eta 1 by E2, eta 2 for every composition. Perfect. Do you agree with me? By measuring this way, you will have eta 1 by eta H2O for every composition.
Yes, sir.
Yes, sir.
Okay. In that case, we go to the next point. Next, I have to go for the, where is the next slide? How to come? Maybe this one? No. Sorry. Actually, my son use it. I am not very, yeah. Okay. So we got another new page. So you have, now we have 0% value, 10% or say 20% value, 40, 50, 60, 80, 100%. What are the values? Eta 1 by eta H2O value we have. As well as we have separately rho 1 by rho H2O value. What you have to do is that now you plot. This plotting you try to learn. Plotting is very important. Plotting eta 1 by eta H2O. Eta 1 by eta H2O. Against the composition 0%, 10%, 20%, 30, 40%, 50, 60%, 70, 80%, 90, 100%. Percentage of ETOH in what? Okay, perfect. Following?
Yes, sir.
Now we have a measurement data. For 0%, we say our data. Now data I am putting in a different color. Data I am putting in say blue color, my favorite color. Data I am putting blue color. So data, we have a data here. Now again we measure for 20, say we have a data here. We have measured for 40, we have a data here. We measure for 50, we have a data here. We measure for 60, we have a data here. Then 80, then say 100. We have data like that. It just data. Data came out like this. Perfect. So this is clearly not a straight line. So this is clearly a curvature. So we draw a smooth curvature. Smooth curvature like this. Okay. So data you can give like this or maybe bigger. Now data can be out of the curvature as well. This curvature, this smooth line actually represents the all the points. It is not necessary that it should go with all the points. This is one scenario. Say another scenario is, let me rub it out. So we have another data set, somebody else has another data set is like this. Okay. Are you seeing this one?
Yes, sir.
Yeah. This data set is discrete. This doesn't have a good trend. Don't feel bad about if you have this kind of data set, because experiment always has error. If there is no experiment, that means you have not done the experiment. Remember, if you try to add 2 ml of ethanol with 2 ml of water, it will never be 4 ml. How many of you don't agree with this one?
What's your state, sir?
You agree or disagree?
Agree, sir.
Yes, sir, we
Why?
agree.
Why?
Agree, sir.
So because the interactions with the two components changes
No,
and hence
that
the
is a
water.
different issue. That is a different issue. Oh, no, I am not telling that partial molar volume kind of things. Say both are ideal. Say both are ideal solution, there is no interaction. In that case, if you add 2 ml in another 2 ml, it will be 4 ml. My point is that in reality, you cannot do that one. Why?
So there will always be a kind of human error.
What is that error?
सर कुछ वॉल्यूम में पार्शियल वॉल्यूम फ्लास्क पे ही रह जाएगा.
The partial volume is another thermodynamic parameter. You don't
So
talk about.
meniscus, we will see it. It will look like that it is 2 ml, but might be it is less than 2 ml.
Sir, temperature fluctuation.
Huh?
Temperature fluctuation will also be the reason for just getting the different type of
Evaporation.
Evaporation, okay, temperature fluctuation, parallax error, and then
human error, sir.
what did you say?
COVID error, sir. COVID error.
Human.
Human error, all these things, human error, and then and anything else? See, in that means there are so many possible errors in your experiment, isn't it? There are so many possible errors. First is that you can never ever have a glass apparatus which will give you exactly 2 ml with your visual eye. You will have a parallax error. Glassware may not be having that kind of standardization. We do not have that kind of standardization, exact 2 ml. And then we have a temperature fluctuation. Maybe you are using 40-degree in the laboratory, so that volume increases. And then so many errors. Where the error goes, the error remains in the experiment. So none of the experiment data should be perfect. So do not worry. Actually, what I said, that 2 ml plus 2 ml, 4 ml is possible only on the paper. Only theoretician can think of that one. In experiment, when you do, you see lots of things, lots of problem. कुछ ना कुछ हो सकते, it will be 4.05 ml, it will be 3.95, 3.97, 3.99, 4.01, anything, but hardly, if it is not by mistake, hardly will get it exact 4.00 ml. So this error is always there. Do not feel bad, do not feel shame, do not feel uncomfortable if your data is not exactly it should appear, but it should be within the error limit. We say within the error limit, like 10% plus minus, 20% plus minus, 5% plus minus, depending on the type of the experiment, type of the devotion, type of the equipments you are using. If you are using measuring cylinder, your error limit will be plus minus 20%. If you are using pipette, your error must be within plus minus 5%. But with pipette, if you are giving 20%, it is wrong. With measuring cylinder, you are telling my experiment is plus minus 5%, plus minus 2%. That means you do not know what is the error. Understood? So take error always in your blood. Whenever you are doing experiment is really great work. In theory, you can do many things. In theory, you can go to sky also. It's imagination. There is no limit. But experiment wise, you will be suffering each and every step. If I tell you to do this one, it's not possible for you at all to do. Where is this one? Where is that one? Whether the alcohol is pure, whether the alcohol is colorless, whether the water is pure, whether the this viscometer is clean. 90% time you will see that nothing is close to perfect. Still, you have to do that, and then you have to try to make it perfect. Cleaning, distillation, all these things. So experiment is really very hard work. So if you see this kind of points, do not feel bad. What should you do? Should you delete all the points? No. Experiment is really great. Whatever you do with full devotion. What you get, try to analyze that one. So now for that, you know that there should be a smooth line which represents all the points. So I'm trying for that one, a smooth line representing all the points. Is it okay? I have tried to plot a smooth line representing all. It is like these are the houses. These are the houses. These are the houses. Say these are the house. These are the house. Now, government should construct a road. Government should construct a road. So government should construct a road in such a way that the houses are more or less same distance from all the houses. You agree? Do you agree or not?
Yes, sir.
Yeah. But say you have a house here, huge house, rich people house here, a politician's house here, leader's house here. What government will do? Government will take the house this way and this way. They will not ignore. They will ignore all. Or we usually experience this one. This is incorrect. What did I say? This is incorrect. Similarly, if you have a wrong point, do not try to take that wrong point inside and make your whole experiment wrong. You should have some explanation that it was wrong. This time I had a phone call, I was chatting with my friend, that's why I could not take the reading properly, that's why this point is there. So this point is not correct. Or if you are really sincere, still you get this point, then you must repeat. Then you must repeat the experiment. Okay, before concluding whether this point is correct or not. Fine? You follow my point?
Yes, sir.
Yes, sir.
Yes, sir.
Clearly following or just accepting?
Following, sir. Following,
Following,
sir.
sir.
Okay, okay. Remember this one. This is not just what I am saying is not just for this purpose. This is usually true. Usually true for in research as well. 100% true for research. So you don't worry about if your points are like that. You make a smooth point. Now you have a unknown sample. Unknown. Okay, you have an unknown one. So unknown means it is within this all composition, because it is also ethanol water. It may be 20, it may be 29, it may be 39, it may be 49. So any composition you make unknown, it must be within this curve, within this fitted curve. Do you agree?
Yes, sir.
This is very important point to understand.
Basically, the point must lie near about the line we have drawn.
Exactly, exactly. This point, whatever the eta 1 and eta is 2, eta x and eta is 2, for this data must be near about the line. Exactly, you said, Nivedita. Fantastic. So now you measure this one. Eta 1 by eta is 2. For this one you measure. Say this point is this one. Since you know which composition, that's why I'm telling here. I do not know what is the composition. So this point on the line, means it can be here or it can be here also, isn't it? Because it is a curve.
Yes, sir.
So problem, is it
So
not a
we'll
problem?
be having two values.
Yes, then we have two values. Here it is 30% showing, here it is showing 60%. Now the problem is that which is correct? For that we take help of another measurement that we have already done. That is the density measurement. So we take help of density measurement and plot the density as well. So for that I use different color. Say for that I am using this color. This color also I like. Say this is the color. Okay. So this is the scale I am making one where P1 rho 1 by rho is 2. Rho 1 by rho H2O. So I plot all the samples, rho 1 by rho H2O with that same scale, with this scale itself. So one is eta 1 by eta scale is this one, and then composition is this one. Here rho scale is this one, and composition is the same one. And then beauty of this is that rho means density change is uniform, means it is not a curvature. This is a uniquely changes. So you will see it will not be giving a straight line because it is not ideal mixture, but the mixture will be like, it will be like this one. Say another points you should use, say here if you use a cross, then you should use another things like triangle, 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 triangle. So your density value changes like this. Now what about the density of this one? Now I must
Excuse me, sir.
deny this fellow.
Sir,
Ayushi.
sir, we will draw the density graph on the same graph of viscosity.
Exactly. Exactly. That is a very nice thing you have to learn. How to plot two graphs on the same page. Who is that question? Who is this discussion? Who has asked me?
Sir, Vidhi.
Vidhi, this is a very nice thing you should learn. How to use the same graph paper where one axis is common, that is the x-axis here, and two y-axis are different. Okay, so your this one is, you see it is gradually decreasing this density. Now measure the density of this one. So density, you expect the unknown density either close to here or close to here, isn't it? Unknown
Yes, sir.
density. So if the viscosity this one is correct, then your density will be close to here. So density indicates which viscosity point is correct. So that means your composition of the solvent is this one, maybe 35% or so. Okay. If your density point is here indicating here, then your composition is this one, 60%. So finally, you can get the composition of this unknown solution by measuring the viscosity and density composition curve, the title says. Okay. All of you students,
Yes, sir.
Yes, sir.
Yes, sir.
happy with the instruction? Are you satisfied with the instruction?
Yes, sir.
Yes, sir. Pretty
Yes,
much.
sir.
Should not be fully, because you have not read the instruction sheet. Once you read, you will have some doubts, and after that, when I clear those doubts, then you should be fully satisfied. Okay. So give me some rest. Ayushi,